Hey, this is a stoichiometry problem involving a percent yield. The percent yield is 65%, so we need to aim for a higher final amount of product than our stoichiometry would directly indicate. All right, so our percent yield is defined as the actual yield divided by the theoretical yield times 100%. In this problem, the amount that we actually want to yield is 1.38 grams. So really what we're going to do is to calculate what our theoretical yield would need to be in order to actually produce this much product at 65%. So we can solve for the theoretical yield, saying the theoretical yield is going to be the actual yield times 100% divided by the percent yield. We'll substitute in our values. We have 1.38 grams. And we find our theoretical yield, or our target yield, needs to be 2.1231 grams. So let's do our stoichiometry problem. We want to get 2.1231 grams of our product. Convert that to moles. Relate that to the amount of our starting material using our balanced chemical equation. Okay, each mole of our iron oxide is going to require 2 moles of our iron 3 chloride. Now we divide by our molarity in order to get liters, because we have 0.200 moles of FeCl3 per liter of solution. Checking our units. Grams, moles. Okay, we end up with liters. If we do our math, this is 0.102115 liters. Let's check our sig figs. We look at all the numbers that go into our final answer. So looking at this, 3 sig figs. This is exact. The 100% is exact, but this part has 3 sig figs. So it's 3 sig figs here. This has 5. This is exact. This has 3 sig figs. So we have 3 sig figs in our answer. Our final answer is therefore 0.102 liters, or we can write it as milliliters, 102 milliliters.